Today I'm gonna talk about this circuitry here. It's a side project I'm also doing. It is a, you can call it a Joule thief, a high frequency inverter, or an oscillator, or whatever. But it is modified. Let me start to begin with, I'm gonna run it on a capacitor bank. These are 2000 farad capacitor, 2.7 volt, 6 of them in series. So the total capacitance is now 333 farads. They are full, not completely full. The voltage is now at 13.38, 39. Yeah, let's say 38. This is the amp meter, so you can see the draw of what the system is running on. I have here a 1 watt LED light bulb. With this clip here I can how you say that, I can remove the loop back to the system, because I have an output coil, which is this one, and this coil here is also a output coil going to the rectifier, to this capacitor, going to this crocodile clip here, back to the source, back to the circuit itself. So when I start it up, I'm gonna let you guys see the milliamp draw with the output and without it by disconnecting this lead here. I'm also gonna show you the difference in input and difference in light when I remove this lead here. And this lead here connects this small capacitor over here across the potentiometer. This lead over here is for me to let you guys see what the system will do when I bypass this capacitor over here. This capacitor over here is on the output coil. This coil over here is this capacitor here is on the output coil. This one here is going back to the rectifier. Hopefully I don't forget to show all this, but basically it's very simple. It is this is the coil. It has a farad core with some tape on it. There's just a hole in the wood so it can stand in its place. Nothing special over there. I will also remove this core, core, and use the coil like this, so you can see what the output will be and what the light will be, so you can see how the system is running without the farad core. Okay, gonna start it up. It is now 13.38. Gonna put it over here. The light is on. It is drawing now 30 milliamps. I tune it to draw on 30 milliamps, which I found the most efficient amp draw, input wise and the output wise on the light bulb also. There is the voltage from the capacitor bank. Now I'm going to remove the output. Let's loop back to the circuit. When I take it off, you're gonna see the milliamps draw. So with output back to the system, milliamp draw is 30 milliamps. Gonna remove it. Amp draw is now 70 milliamps. The light is brighter. Put it back on one more time. Milliamps draw 30 milliamps. The light is a little dimmer, but still pretty good. So I'm putting back with this manner 40 milliamps back to the system itself. Now I'm gonna remove this lead here. Milliamp draw is 30 milliamps. Removing the cap. Hold it here. It is removed now. Milliamp draw is now 35 milliamps, 5 milliamps more, but the light is also less. I'm gonna connect it here and let you see. Hopefully you can see that in one view. Connecting it, light is brighter. Disconnecting, gonna put it closer. Connecting, disconnecting, connecting, disconnecting, connecting, disconnecting. And when I do that, connecting here and disconnecting, look at the milliamp draw. Disconnecting is at 35 milliamps, connected 30. So this capacity here, which is across the potentiometer, helps me to decrease the input milliamps draw and give me a little bit better light. As you can see, the voltage just dropped from 13.38 to 37 and is now 36 volt DC. Now I'm gonna show you what happened. It is still drawing 30 milliamps. Now I'm gonna show you what happens if I bypass this capacitor over here. When I bypass the capacitor, no lights. With capacitor, I have lights. No capacitor, no lights. With capacitor, I have lights. And with capacitor is 30 milliamps. Without bypassing the capacitor, it's almost 50 milliamps. So with the capacitor, I have a lower milliamp draw with light. Bypassing it, I have no output with 20 milliamps more. So for me, is this another good improvement? I have had this circuit for a pretty long time now. So this capacitor here, wonderful. This one over here, this one is across the potentiometer, perfect. This one is in series with the output coil over here, then it goes to the bridge rectifier. Now I'm going to remove the ferrite core. Here it is, removing it. There's nothing there, just a hole in the wood to keep it in place. I'm going to put the coil as this without the ferrite. I have no light and the input is now 45 milliamps, so it's 50 milliamps more and I have absolutely no light. So this ferrite core does a pretty good job in helping the system out. Let me get it in place, looking for the hole. Okay, introduce it back up. Now I have lights and input milliamp is back down to 30 milliamps. The voltage now has decreased to 13.35 volt DC, so it's not bad. Let me give you all. This is in total darkness in my small laboratory here. I'm gonna show you the lights. Hope I don't get a shock myself with this EC. Wait for it. As you can see, oops, I'm shorting out the coil here, the load, the light bulb. You can see it's not bad. I can see my own circuitry with it. See the voltmeter, the capacitor bank, the input draw, still 30 milliamps. So, and of course I can play with the potentiometer to get, I go to the maximum input draw I can achieve with this setting. Is 55 milliamps. Light is a little bit better, not much, but it's also draining more. Voltage is now 13.34, but I like to keep it at 30 milliamps. I can go lower also. The lowest I can go with this setting is, as you can see here, it's about 15 milliamps. At 15 milliamps I still have some lights. Not bad. If I remove how you say that, the loop back to the circuitry, I'm gonna remove it. Now it's running on, yeah, let's say 42 milliamps though, so it's roughly 25, yeah, 27 milliamps more. Engage it back. I can also remove it here, but I have to be careful because this capacitor get filled up very quick by the output. Removing it, as you can see, even higher input now. Oops. That's why I don't like removing it over here. For that reason, don't want to blow up that capacitor. That's why I'm using it here. But as you can see, there's a difference when I remove it here and here. So yeah, one more time in the dark. This is now on its lowest setting, which is, oops, keep shorting the lights. Come on, man, help me out here. Wait for it. There it is. At 50 milliamps, the light is not bad. You can even use it to read. It's a little bit brighter in real life than on the camera. I think the camera is compensating for the light. Okay, I'm gonna put my digital meter back on. Gonna tune it back to 30 milliamp, which I find has the best input and light. It goes pretty bright at just around 30 milliamps. Don't know if the camera can catch that. Anyway, 30 milliamps. Yeah, that's about right. Oops. The voltage in the capacitor bank is now 13.33, 32. One more time, removing the input back to the system over here will cause it to draw more, from 30 to almost 100. Have to put it back on quickly. And over here, removing it before the bridge rectifier, I think it's still getting some energy from the other side of the AC, which is coming from the capacitor over here. Removing it here, I get, yeah, say 72 milliamps. And now it's again at 30 milliamps. Let me tune it a little bit more. Precisely 30 milliamps. Which is a bit of a pain sometimes. Gonna remove the capacitor again. 35 milliamps with lesser light. Put the capacitor back in place. A little bit more light, as you can see on the camera, and it is back to 30 milliamps. Gonna short this capacitor over here. Not short it, gonna bypass it, so it's not in the system. You will see the lights go off and my milliamps go higher. Bypass it now, no lights, and I get 47 milliamps draw, which is about yeah, say 70 milliamps more, but no lights. Let it go, put in the system. System is efficient, more efficient. I have light and at 30 milliamps. The capacitor bank is now at 13.31. It's not bad. I still got some ideas to do some testing with, yeah, a few other configuration of this coil, because when I put it completely at its highest resistance and makes it draw only 50 milliamps, so 50 milliamps, I don't know if I can get that out of the system. If that is possible, then I will have light and a kind of a self runner, but I don't know. I don't see that coming from the system itself. Maybe I can use an earth ground, something like that, but don't know much about that. But I do know earth ground is negative, so for the electrons of energy to flow from the earth ground to the system where I connect it have to be positive with positive charge. Anyway, what more can I say about it? Yeah, input capacitor. This transistor here is a basic tip 355 3055, which everybody uses on the pulse motor. I have a potentiometer here for the base, and this capacitor here, a small one, is across it, so you can say it's parallel with those two lines from the capacitor. This capacitor here is a high voltage capacitor. It's a 1.6 kilovolt. It's in series with the one of the output of this coil, and then it goes to the bridge rectifier over here. I think that's about it basically. And this ferrite here, ferrite core, is a Russian grade, high quality Russian grade ferrite core. You can find them on eBay. Let me think here. Am I forgetting something? This output coil, this one here, is for the output lamp over here. It's 2 wires. This I think you call it like Tesla bifilar. I think you call it like that. Not pancake style, just one together, connect in a series, you get it. And over here, the driving coil, of course it is a la Joule style, and I also have in there with the driving coils 2 similar coils as this one, and that is the output that goes to over here and back to the input. Hope that makes some sense. The leads are a little bit loose over here. The voltage of the capacitor bank is 13.30 volt DC, so a heads drop 0.08 volts in this 50 minutes, I guess I'm talking now, of filming now. Anyway, just having some problem with the leads over here to keep that in place. That's why yes, yeah, gonna tune it back to 30 milliamps input, which I find is like a sweet spot. Yeah, I think I showed more than enough. This is just something I do. Take a break from the pulse motor. Not that I haven't done anything, because I just wound the second generation of that ugly crappy coil I had. This is the first generation using this one. I wound another one. Here you can see the core, air core. You can see through it. Hopefully this bobbin is stronger, so I don't have to put tape on it on all the sides. But maybe I will put tape on it just in case. It is done, we'll be doing testing. It is basically the same, but with a little bit different configuration. And hopefully I improved the problems I was having, or solved them, and with better output, or maybe not. Anyway, that's another video. Hope you enjoyed this video of my modified pulse motor, or high frequency inverter, or oscillator, whatever you want to call it. It's pretty efficient. If I can make it run better, I will make a video again sometime. Hope you enjoyed it. Thanks for watching.